Alright, so we got Unit 2, Lesson 4. Okay, this is kind of the last factoring one before we get to solving. Okay, I do have, a lot of you aren't on Moodle yet, I do have a list to let you know, but I can see if you're on Moodle or not. If you're not on Moodle, get on there, but there is a pretty good Khan Academy video that just has a basic overview of all factoring. I think it's actually built in like 11 minutes, so if you're just really struggling, just want a little quick help, that'll work. Okay, again, rewatching the lessons. You don't have to watch the whole lesson, just watch a couple of examples you understand. Maybe listen a second time. It's very simple stuff, okay? Like I kind of put in my course outline, you probably already forgot, but, take pride in your education, okay? Have a little bit of, drive to try to figure things out for yourself, because that's when you really learn. If I'm always telling you the stuff when you get the test, it's not going to come, okay? So make sure you kind of get yourself in the rhythm of being accountable for yourself and what you're trying to get done, okay? That's what I would like to see from you. And that's when I get happy, is when I see you guys taking advantage of your opportunities that I give you. Okay, so this one is, we're factoring kind of it's pretty much a big difference of squares section. It gives you a really ugly, but it still is a difference of squares, because you got a difference, and you have everything is squared, right? So yesterday, what was the difference yesterday? Yesterday was just factoring, but what was the problem or what was the issue? What do you think, Kyle? What was different yesterday than usual? You remember? Not really? Who remembers yesterday? Yeah, substitution, but what was the, Sam, what was the difference in the problems that, made us kind of, take a step for a second, wait, what does that mean? Yeah, the exponents are higher, right? The pattern of the exponents, and we talked about the pattern of exponents, we still want them to be in the form of 2, there we go. We want them in the form of 2 to 1. So yesterday, we talked about we always want these right here to be 2, 1, 0 pattern. Or x4, x2, c0. We always want it to be twice as big. Okay, well, when I'm doing difference of squares, we want to recognize the pattern still. Okay, so it's the same thing as yesterday, but now we're looking at difference of squares. So we're going to go ahead and just expand this here by foiling. Whoops. Erase that one there. We don't want to do this. Okay, so ax times ax is a squared x squared. Ax times by is, I'm going to write this up here because I'm going to simplify it, ax by. Negative by times, it's a bad A. Negative by times ax is a negative ax by. And then negative by times by is negative b squared y squared. So you can see again, the middle cancels. Okay, again, the middle cancels. That's kind of the point. Okay, and so the factored form is just kind of going back and forth now. So your factored is ax plus by, ax minus by. Okay, anything yet? Okay, so let's do these examples here real quick. Whoa. Holy moly. Oh. Try this again here. That was weird. Okay. Alright, example 1. So, let's take a shot. Adam, what do you think for number 1? What's it going to be? Not sure. What's square root of 9? 3. So it's going to be 3x. Okay, square root of 16? 4. So it's going to be 4y with a minus 4y as well. That's it. Okay. Alright, let's challenge Quinn here. Quinn, what should I do with b before I freak out because of the odd numbers? Yeah, 3 and a what out? It's a little bit of everything out. 3x and a y, take that out. We don't like odd numbers, right? So if we see odd numbers, it's like, okay, can I GCF? So I took a 3x and a y out because they all have a 3x and y. So that gets me x squared inside, gives me minus 9y squared. Now factor that. You want to finish, Quinn? So would that piece we have left be factored? Good. Good. So we just broke this one down because it's a difference of squares. That's a perfect square. That's a perfect square. X minus 3y, x plus 3y. Very good. Okay, Lauren, what do you think on number part C? Okay, both by 4. Okay, fair. So we take a 4 out first. Okay, and what's that break down to? Good. That's it. Yes, sir. Yep. So all Spencer did is he didn't pull out the 4 in the beginning, which is fine, except for his answer is not going to be simplified all the way because you're going to have that, and then the plus 1. Well, 12 and 2 have something in common, so just it's still right. It's just not simplified as far as possible. Okay, because I can still take a 2 out of that, right? Okay. Anything else before we get to the story problem here? Or not really story, just word problem, I guess. All right, let's look at this one here. All right, so what we got here? All right, pane of glass is a rectangular with an area of 49x squared minus 16y squared. Okay, the length and width of the pane of glass can both be written in the form ax plus by, where a and b are integers. Determine the appropriate values of a and b, and hence write the expressions in x and y for the length and width of the plane. So what we want to figure out is we need to understand that the multiplication, the length and the width, will equal the area of the rectangle, right? Length times width, area of rectangle. Now you may be saying, well, wait a second, this is difference of squares. Won't they be the same size? Like, are they the same? Are the numbers the same? Wouldn't that be a square? Well, no, because difference of squares. So let's factor this real quick. What's that factored? What do you think, Davin? What do you think? (7x minus 4y, 7x plus 4y). Those are different, right? So I'm going to call this one my width and this one my length. Okay, just because length is generally longer usually, right? So I'm just going to put length with the addition. Doesn't really matter. You'll still get the right answer in the long run. Just makes logical sense for me to do that way. Okay, so we've identified our length and width. That was the first part. So what's part B say? Given the length of the pane is double the width and the perimeter is 56 feet, develop a strategy for determining the length and width of the plane. So what is the information that's going to help us figure some stuff out? What's the number there that's going to help us? 56 in perimeter. That's where we can actually associate a value now. So we can actually associate a value with what they're giving us. So I'm going to do my work up here a little bit. So if we know it says the length is double the width, so I know that 7x plus 4y is equal to 2 times 7x minus 4y. Okay. We're just going to hold on to that for a second. So what's perimeter mean? Let's take a step back. What's perimeter mean? Sum of all sides, right? So when you're doing sum of all sides of a rectangle, how many lengths do you have? Nope. Rectangle. 2 lengths, 2 widths, right? So I'm going to go 2 of my lengths, and I'm going to go 2 of my width equals 56. Okay, it's going to be a little bit old school here. We're going to have to solve using a system of equations, if you remember how to do that. Okay. All right, so what do we know about this? I believe that's what I did here. 7x plus 4y. Yeah. So we know that 7x plus 4y equals, I'm going to distribute that, equals 14x minus 8y. So we know that 7x, that's what 7x plus 4y equals. Okay, and so what we know, and this seems kind of redundant, but we know that what does this represent right here? This represents length equals 2 times width, correct? Can you see that this guy is right here? So I can take that, I can put it right there. Okay, so I'm really going to take this and put it right there, though, because that's a simpler way of putting it. So we're going to have 14x, I know this is getting a little bit messy here, plus 8y plus, and I'm going to put this in, 14x minus 8y. Can look at that. Why does that help us big time? What happens? What's up? Yeah, it's common, but looking at what I just wrote, I mean, when you're doing system equations, what's your first goal? In order to solve something, you have to do what? Just think general for algebra solving. Isolate a variable, right? We have 2 variables right now. If you see what I just wrote down there, what do you notice? I have a positive 8y and a what? Negative 8y, so they're going to go away, right? So they're going to go away. Again, let me walk you through how I got that again. So we know that 7x plus 4y equals this. Okay? So what we did is we entered this in for that. Okay? And we distributed this out. The 8y's cancel. So now we have 28x equals 56. 28 is, x is 2. So we have x is 2. Now we just need to figure out what y is. Okay. All right, let's see here. How do I get that? Oh, okay. Okay, and to figure that out, so we're going to minus this over, because we're trying to figure out y now. So we're trying to make one side equal to 0, which these cancel, makes this side 0. So 0 equals 7x minus 12y. That's what 0 equals. 0 is equivalent to 7x minus 12y. We do know what x is, so I can put a 2 here. 0 equals 14 minus 12y. This one is a fraction, so that's okay. Let me get out of the way and then I'll explain it. Okay, so 7/6 ends up being what your y is. 7 over 6. Okay. All right. So kind of just walk through it one more time. So, I mean, I guess I might have emphasized this point when I didn't really need to, but if you see this right here, if I just distributed 2 and the 4, I get 14, 8. If I distribute it here, I'd still get the 14 and the negative 8. So that's, I guess you don't have to plug it in there. So if you're wondering why I did that, I guess you're right. You don't really have to. The other thing is, just the key is getting rid of a variable. Okay, and then what I did to figure out y is I just went to, we know that these two are equal, because that's what they told us. We know that one length is 2 widths. So we just took advantage of that, and we moved all the stuff to one side so we get an actual number, which is 0, and then we can plug stuff in for x to where we have one variable again, and we can solve for y. Okay, that's essentially what we've just done. I know it was kind of long. Is there any questions on that? Okay, so then when we go to the question here, it wants to know what the length and width is. So length is here. So that's going to be 7 times 2 plus 4 times 7 sixths. Okay, and that just works out 14 plus 28 over 6. So you're going to end up having a little bit of fractions, but it ends up being 18 2/3 if you change to a mixed number. Okay, width we know is that one. So 7 times 2 minus 4 times 7 over 6. And that gets me 9 1/3, which not coincidentally is half of 18 2/3. Two of these makes the length. All right. All right, no questions, or you guys already wore out? Wore out? Yeah, fair enough. Does get easier. That was kind of hit you hard with the first one. All right. Okay, so what this is talking about here is that be careful when you do your difference of squares, make sure you can't do it again. Okay, so that's pretty much what this is all talking about, is when you do your difference of squares, make sure that there's not different squares again. Because that happened a lot of times for some of you guys on your homework. You'd be like, I don't have the answer the back has. Well, it's because you can break down the x squared minus 1, right? You can do it again. So let's just do a couple of those. We're on about the home stretch here. Okay, so what we're talking about is this is still an even. Okay, it's still a 4. That's still a 0, so that's okay, and that's a perfect square. We need to understand that K4 is a perfect square. What times itself gives you K4? K2, do we understand that? So that still makes this a perfect square. So it's still a difference of squares. Yep. Okay, so now we're going to go K squared plus 1, K squared minus 1. And this is what they're talking about above. This right here, again, can be broken down. So this can't, it's not a difference, so that stays. So I have K squared plus 1, K plus 1, K minus 1. That's completely broken down for part A. Okay, I just had to break down that second one because it's a difference of squares again. Yep. Which part? So this right here, are you good with? Yeah. Okay, this right here is also a difference of squares, so we need to do it again. Because it's a minus, right? Is K squared a perfect square? Yeah. K times K. And is 1 a perfect square? Yeah. 1 times 1. It's a simple one. And so that puts you, these two come from that. Yeah, it's just kind of like it's layered, I guess you could say. We're kind of doing it twice. Okay, so let's move on to B. Okay, sorry if we don't get the first one. We just got 3 to go. What stands out on B that might be like, why? Liam, looking at B, what's your first thing and you're like, I don't get it? The different letters. Okay, different letters. Okay, what else do you see? What's that, Tom? Yeah, the numbers aren't perfect squares, right? 80 and 5 aren't perfect squares. So then what should you think about doing? Yeah, making them by GCFing. Pulling a 5 out, I think I heard. So pull a 5 out. If I pull a 5 out, that makes it 16A4 minus X4. Now we feel more comfortable? Okay, they are different letters. The letters doesn't really matter because is A4 a perfect square? Yes. Is X4? Yes. So the 5 just kind of hangs out. Just know it's just always going to be down here, your answer at the end. Okay, but here we go. It's going to be 5 times 4A squared minus X squared, 4A squared plus X squared. Am I done? Which one's a perfect difference of squares again? Yeah, this guy right here is another one. So I'm going to go, that's going to break down to what? Is that going to break down to, Tom? That's your full answer right there. That's all of it. Crazy. Okay. Again, for next class, a little advanced thing here. This creates a 0. This creates a 0. That's a square. It creates 2 zeros. So how many is that? 1, 2, 3, 4. What's our exponent in this problem? That's not a coincidence. Let me say that one more time. That makes a 0. That makes a 0. This makes 2 zeros. 1, 1, 2, 3, 4. 4 is the exponent. That's how it always works out. Okay, all right, and C. Okay, again, I got a 5, so I'm freaking out. I got a 2 and a 162. They're not helpful to me, so I think I'm going to try to take a 2p out. Okay, that gives me P4, Q4, minus 81, T4. Now I feel a lot better. Okay, because now I have perfect squares. Okay, so we do it again. 2p just hangs out. P squared, Q squared, minus 9, T squared. And I have the other one here. It's going to be the plus. I'll write in a second. I don't have room. I'll write in a second because, again, all these are perfect squares. 9 and T squared is perfect square. I can break this one down again. So here we go. 2p, p, q, minus 3t, pq plus 3t, and then the one I forgot, p squared, q squared plus 9t squared. That's your complete answer there. All right, a couple more here. Time's flying. All right, so then these ones, what do you think you want to do for these ones? What do you think? Have any guesses? People missing today. What did we do last class? When you had this, yeah, let's go and substitute. Okay, let's make that an A. So I'm going to say A equals B minus C. So A squared minus big A squared, that's a difference of squares. A plus big A minus big A. Now I put the big A back in. A plus B minus C. A minus B plus C. So minus makes them change the opposite. Say that one more time. Because I put this right here. The positive B is now a negative B because of the minus. The negative C is now a positive C because of negative negative. Okay, this one, let's go ahead and do 2. Say A is 2x minus y. Let's say big B is x plus y. So I have A squared minus B squared. A plus B, A minus B. And now we plug it in. So the first one, I'm going to have 2x minus y plus x plus y. We'll combine like terms in a second. 2x minus y minus x minus y. They both get the negative. So here I have 2x plus 1x. In the first one, I have 3x. I have negative y plus y. It's gone. Over here, I have 2x minus 1x. That's just x. Negative y and negative y is negative 2y. And we're good. One last question here. Deep breath. Okay. Okay, so this one's a combination one. So again, I'm probably going to do an A and a B. Okay, 36A squared minus 49B squared. 36 and 49 have a common factor? Nope, it doesn't. Okay, so we feel good about that. So it means we're going 6A minus 7B, 6A plus 7B. Now we insert our stuff back in. So 6A, we're going to do a little bit kind of at the same time here. It's going to look like this, 6x and 30. So this is going to be a 6x and plus 30 minus 7 times b, be 7x, so minus 7x, and then a minus 56, a minus minus is plus 56. So that's what that one looks like, the left side. The right side, we already know it's still 6x plus 30, and then 7b is going to be plus 7x minus 56. Now let's combine like terms and finish this off here. 6x minus 7x, negative x, negative 1. 30 plus 56, 86. 6x plus 7x, 13x. 30 minus 56, negative 26. Could take a 2 out there probably, but I will leave it right there. Yeah, that'll work. All right. Okay, so this one is for Mark today. Sure you do that.